Welcome to our class in quantitative methods. In this class, we're going to discuss a number of topics. Our first and easiest topic is descriptive. Descriptive statistics, we're going to look at grouped data and ungrouped data. We're going to look at grouped and ungrouped data. So I'll start with what you know to what you don't know. So whenever that is scattered randomly, like you can see. So we have 3, 7, 8 just scattered. It's not yet put in clusters or grouped. And whenever we're dealing with group data, we're looking at classified data, which is put in clusters or classes. So before we go into the nitty-gritties of calculating what are called measures of central tendency and dispersion, we're going to go through grade 12 work by understanding the above pictograms. So we have A, B, C, D up to I, which I need you to identify. What is A? What is B? What is C? Anyone?
It looks like pie chart.
A is a pie chart, yes. B?
The bar graph, maybe?
Yes, the bar chart or bar graph, yes. And C?
I'm guessing histogram.
Yes, the histogram, correct. And D, the line, the midpoint. It's an object line that joins points that have the same the midpoints. Then E is called a cumulative frequency graph because it's cumulative. Then we have the relative frequency graph, which falls down. Then GH, these are histograms and bar charts, except they're in a different format in the donut, which is another format of a pie chart. So you've seen this in Excel. Okay. So when we are dealing with ungrouped data, the first thing that you need to do is to rearrange your data in order. So if you're given 2, 5, 3, 3, we have 9, 4, 9. So the first thing we rearrange in order, starting with the smallest. So which one is our smallest figure here? We have 3.
And 2.
We have 2. Then?
Yeah, it's 2. Looks like 2, 3, 4, 5, then 9.
We have 2 3s. And 4. Then 5. Then 9. And another 9. Okay. We agree with that so far. We've arranged it in ascending order. So we're going to square each of these ones here. This 2 times 2, 4. And here we have 9, 9. Here we have 16, 25, 81, and 81. The sum of this is called summation of x. The sum of this is called summation of x squared. So we get to the sum later. So since we've identified them in ascending order, so we start with the range. The range is the difference between the highest number and the smallest number. So x max minus x min. What is our highest value?
9.
9. And our smallest value?
2.
So our range therefore is 7. Our mode is the number that appears the most. So which numbers appear the most here?
Looks like 3 and 9.
We have 3 and 9. So this is a bimodal frequency. 3 and 9 appear the most. Like I said, for those of you who just joined, this is an interactive class. I need everyone to be participating. This is a killer course. Many people repeat because they underrate even the smallest things. Then we have what are called the quartiles. We have 3 quartiles. We have the first quartile, which is called Q1. It gives you the position, simply a quarter of n plus 1. A quarter of n plus 1. So n is the number of the elements. How many do we have? How many do we have?
7.
7. So 7 plus 1?
8.
8. And the quarter of 8 is what?
2.
So in that order, which one is the second number?
3.
3. So we have the second quarter, which is half of n plus 1. So what is our n? 7. 7 plus 1 is 8. Half of 8, what do we get?
4.
The fourth position. So which one is the fourth position in this order?
Yes. 4.
Coincidentally, it is 4. Then we have the third quartile, the upper quartile. First, the second quartile is also called the median. The first quartile is also called the lower quartile. And the third quartile is also called the upper quartile. So the third quartile is 3 quarters. What is 3 quarters of 8? 3 quarters of n plus 1. 3 quarters
6.
of 8 is what? 6. Which one is the 6th number?
9.
9. Good.
Yes, sir.
So 1, 2, 3, 4, 5. So 9 is our 6th number. So how do we get our interquartile range? Interquartile range is generated by IQR. Interquartile range is simply the third quartile upper quartile and the lower quartile. So what is our interquartile range? The upper quartile minus the lower quartile. So what is our third quartile here? 9. And the lower quartile or the first quartile is what? 3. So 9 minus 3, 6.
6.
Then there's also what we call the interquartile, the semi-quartile deviation. Semi-quartile deviation is half of the interquartile range. So half of 6 is what?
3.
Half of 6 is what? Is 3. It's called the interquartile range. So for the Q1, Q2, Q3, suppose the number here was the way our n was 8. 8 plus 1 is 9. So if your Q1, you get maybe 2.25. You round off the nearest figure, it will be 2. If our Q2 was 2.5, you add the second and the third, divide by half or divide by 2. So second number and the third number divide by 2. The number which is appearing here, if you had 7.5, 7 and 8 divided by 2, that will be your median. 19.5, 19th and the 20th. If your Q3 was 2.75, you round off to the nearest one number, which is 3. That is how we do in case you have a decimal point. So we've done the measures of dispersion. So central tendency, let's total up this column and that column. So what do we have? 6, 10, 12, 17, 26, 30 what? 35. 35, right?
Yeah.
Then here when you total up, what are you getting? Please quick with the calculators. What do we get with the calculator? Always have a calculator nearby, the book and the pen. You can't be in this class without any of those. So you're calculating. So those that have joined, I say those that are based in dollar, attend also the physical classes so that we move. My idea is to be ready before the residential start. We'll go through the previous exam and the previous test papers so that you're not blank as you start residentials. What's the total here? What total are you finding, please? Let's redeem time. Now you have calculators nearby. What total are you finding? If you can't speak, you can just text, put in the chat button there. Just an issue of totaling up. I don't have a calculator here, unless I use my phone. Quickly. Yes,
I
Evan?
think it's 225.
What are you finding?
225.
225. Okay. 225. Okay, great. So we have our summation of x as 35 and our summation of x squared as 225. So the mean is denoted by the symbol x bar, which is given by summation of x over n. So this is given by 35. Our n was what? 7. 35 divided by 7 is 35. N was the number of elements we had. Then we have what is called the variance, sample variance.
Okay, the mean will be 5.
It's 5. Not 35, it'll be 5. Thank you. So the sample variance is given by summation of x over n, everything over n minus 1. So here we have 225 minus 35 squared divided by 7, everything over 7 minus 1. So you start from here. 35 squared divided by 7, what we get? 15 carry 1, 165. So 225 minus 165, what we get? 0, 6.
Sorry, I'm getting 175.
175? Okay. Yes, actually 175. So 225 minus 175, what are you getting? 0,
50.
50, right?
Yes.
50 divided by 6. Our variance becomes what?
8.3.
8.3 what? 3 days or 333. Okay, the variance given by a squared, or population variance, is a sigma squared. When we square root our variance, we call it what? The standard deviation. So what's the square root of 8.333? What is the square root of 8.333?
2.8. 2.887.
2.887. Okay. Then we go to what is called the coefficient of variation. Coefficient of variation. Coefficient of variation. Coefficient of variation is given by the CV is equal to standard deviation over the mean times 100. So we found 2.887 and our mean was 5 times 100. What are we getting in percentage?
$57.74.
67.74%. Okay. Then we go to coefficient of what? Skewness. Coefficient of skewness. This one is given by 3 x bar minus median divided by standard deviation. So this is 3. Our median is 5. Our standard deviation is 5. Our median was the second quartile. What was our median? We found 4, right? Minus 4 divided by our standard deviation, 2.887. So what do we get? We get
1.039.
1.039. For the skewness ideally gives you an idea whether you have a negative or positive skewness. Skewness looks at the distribution. If your answer was 0, you say it's normally distributed. If you got 0, it's normally distributed, it's normal. If you get a positive, you say it's skewed to the right, or it's positively skewed. If you get a negative, you say it's skewed to the left, or negatively skewed. That is a comment. They usually ask for a comment. Okay. So this is what we do with measures of central tendency with ungrouped data. With grouped data, we already understood how group data looks like. It has classes 1 to 5. 10, 15, 20, 25, 8, 6, 7, 16, 1, 6. Then you'll be given frequencies. So the given frequencies, for instance, 1, 3, 7, 1, 3, 7, 9, 5, 2. So this is all you're given. So to find the height, you just find the difference between any bounds, the lower bounds or the upper bounds. So our height is 5. Don't subtract them because sometimes it's not adjusted. You may get a 4. So the safest you find the differences between the lower and the upper bounds amongst themselves. Then you have what is called the cumulative frequency. It's an add-on. 1. 1 plus 3, 4. 4 plus 7, 11. 11 plus 9, 20. 20 plus 5, 25. 25 plus 2, 27. This 27 must always be the sum of the frequency here, which is 27. So far, any questions before I proceed? Any questions before I proceed?
Just on the height, what did you say on the height?
The height, you get the difference between the lower bounds and the upper bounds. From 5 to 10, 10 to 15, the difference is there. Sometimes you subtract if they are adjusted. You need to readjust this by subtracting 0.5 here and add a 0.5 there. That's when you can subtract. better to get them as they are. So if you're adjusting them, you add a 0.5 here, 0.5, 0.5, and subtract 0.5 from the lower bounds. But the new class, if you want to adjust it, the new class will be 0.5 to 5.5. Here, subtract 0.5 would be 5.5 to 10.5. But the top one just add 0.5. So this will be 15.5, 20.5, 5.5, 30.5. And these ones will be the same, just drop them down. 10.5, 15.5, 20.5, and 5.5. Now you can subtract 0.5 from 5.5, is to get your height of what? Of 5. So if you have not adjusted it, it becomes tricky. Here we've got what is called the midpoint. The midpoint is found by adding the lower bound and the upper bound divided by 2. So 1 plus 5 is 6, divided by 2 is 3. 10 plus 6 is 16, divided by 2, you get 8. Now, since we had a height of 5, the easiest one, just keep adding 5 throughout. So this will be 13, 18, 23, and 28. It is the same as adding the lower bound and the upper bound divided by 2. You still get the same answer. So your height here is simply still what? Still 5. So when you square this, 9 and 64. You continue until the end. Okay. So here we have fx and we have fx squared. So the f is 1 times, so we can put this column 1, column 2, column 3. It's simply column 1 times column 2. It's simply column 1 times column 3. So 1 times 3, we get a 3 there. 1 times 9, we get a 9 there. Then we go to the next one. 3 times 8 is what? 24. And again, 3 times 64, we get 12, carry 1, 19, 192. The mistake people make is squaring this to get this column. Okay, so let's go. How do we get the next figure here?
We square 13.
Yes, which is what? 169. Then here, 324.
4.
The next,
529.
and finally, 28 times 28.
784.
784. So how do we get the figure here? A, B, C, D, E, F, G, H, I, J. At least everyone should say something. How do we get the answer at A? At A? Yes, Shadrach. How do we get the answer at A?
At A, we say by 13.
What we said A? So what do we get? 7 times 13, what do we get?
91.
91. Confirmed? Yes. Next, at B, or A and F. And F, how do we get F? Same Shadrach?
If we say 91,
Mhm.
91 squared.
That's what I refused. I said never make a mistake of squaring this. You always start from this times x squared. So 7 times 169. What do you get?
7 times 169.
Mhm.
Okay.
1183. Okay. Maurice, then Joseph, in that order. Next, at B, what do we get?
There we do to be 9 by 18.
Yes, 9 by 18, what do we get? 162. And here at G, what do we get?
G will be 324 by 9.
Yes, which is what? 916. Joseph, then Evans, in that order. Yes. Five times what? Yes, Joseph. 5 times 23. Then again 5 times what? 529, which is 26, 45. Yes, Evans, last. Evans,
Pardon me, I'm actually on the road driving, so
you're following.
I'm listening.
Okay.
Yeah, I'm following. So
Great. Okay, Rachel and Rocky, in that order. Multiply 2 times what? 28, which is 56. Then again 2 times what? 2 times 784. What do we get? 1568. I'll give you homework based on just what we've covered today. Then we just need to total up this column, and that column. So what total do we have here? Okay, the ladies total this, the gents total this. In that order, let's move together. So 9 plus 192 plus 1183 plus 2960 plus 2645 plus 1568 get 140774. 0.074. This is our summation of fx squared. Summation of fx squared. So the summation of f, what we get? Three plus 24 plus 91 plus 162 plus 115. So what total are you getting?
$451.
What total?
$451.
451. So 451. The summation of fx. So to find the mean, our mean is simply summation of fx over summation of f. So 451 divided by 27. What are you getting?
$16.70.
Hold on.
16.70.
16.70.
Yes, 16.7037 to 4 decimal places.
$16.70, is that confirmed?
Yes, 16.70.
Okay. Then for the variance, summation of x squared minus summation of x to the power 2 over n. This is for a sample. Now you see that the similitude is very high. For group data, we're just adding an f. So over our n is the same as summation of f divided by summation of f minus 1. So what do we have here? 14074. 14074 minus, we have 451 squared over our summation of f is 27. Everything over 27 minus 1. What are you getting? Start from here. 451 squared over 27. The answer is subtracted from 14. What are you getting? this part is giving you 7533.37.
Okay, it's giving 251.56.
The final answer?
Yeah.
Okay.
251.56.
251.56.
Correct.
So this is our variance. Meaning, what is our standard deviation? When you square root that,
15.86.
15.86.
Yes.
Then the coefficient of variation is simply the standard deviation over the mean times 100. So what was our standard deviation? 15.86, and our mean 16.70. 15.86 over 16.70. What are you getting as a coefficient of variation?
0.9497.
And 4.97%. Okay, so I will end here.